morning, girls. Welcome to class 9 where we are learning Science 1 and our lesson is going on acid, bases and salts. Before going to the today's topic, I just would like to inform you about the activity which you have to do, as you have got the message. On that message you have read that you have to make a 1-minute video. The topic which have given to you, one is you have to determine the pH value, and the other one is positive work, negative work and zero work. Any one you have to attempt for your 1-minute video, and the further instructions you will get on the Google Meet when we will do the Google Meet. As today I have to go to the school, so I cannot take the live class. That's why I'm sending the video for today's topic. But on next period, when we will meet on Google Meet, then I'll tell you the further instruction for your activities. Till then you just prepare. Your section subject teacher of Science 1 will take that activity on Google Meet, and then they will select one person, one girl for making video. Okay, there will be a group of 10 girls, and roll number wise 10 girls will present their 1-minute video on Google Meet live, and one girl will select it for the making 1-minute video. And I'll tell you another instruction on Google. Till then you just prepare for it. And now we will go to our today's topic. As we have studied in previous class about types of salts, that acidic, basic and neutral salts, and water of crystallization, ionic compounds and electrical conductivity. Today we are going to study that dissociation of ions and electrical conductivity, electrolysis and electrolysis of water. So as we have seen in previous class, that which compounds produce have conductivity, have high conductivity and have low conductivity. So here you can see that ethanol have no conductivity, KCl high conductivity, acetic acid solution have low conductivity. So today's topic is about dissociation of ions and electrical conductivity. So in the above activity which we have studied in previous class, we have seen that it was found that the aqueous solutions of the compounds, that is NaCl, CuSO4, H2SO4 and NaOH, are electricity conductors, and out of this NaCl and CuSO4 are salts. H2SO4 is a strong acid and NaOH is a strong base. So we have seen the salts, strong acids and strong bases dissociate almost completely in their aqueous solution. We have seen this. So therefore the aqueous solutions of all these three contain large number of cations and anions. So a characteristic of the liquid state is the mobility of its particles, and due to this mobility, the positively charged cations in the solution are attracted towards the negative electrode or cathode and move towards the cathode. Mobility means the movement of particles, and as we know that when they move, so positively charged cations, we call them cations, and they attract toward the negative electrode, or we can call it cathode, and move toward the cathode. And on the other hand, the negatively charged anions move in the direction of the anode, and the movement of ions in the solution towards the respective electrodes amount to the conduction of electricity through the solution. So from this you will understand that those liquids or solution which contain large number of dissociation ions, they conduct electricity. Now we will go to the next topic. Dirty pieces of copper and many other metals undergo several processes before they are reused. And one such fascinating process is electrolysis. We call this process is electrolysis. So electrolysis is a process in which an electric current is used to bring about a chemical reaction. We don't see bubbles in water normally, right? But when an electric current is passed, we see bubbles rising to the surface. These bubbles are of hydrogen and oxygen produced by decomposition of water by electric current. The process is carried out in a device called the electrolytic cell. An electrolytic cell consists of a non-conducting vessel, two electrodes, electrolyte and battery, as you can see in the diagram. The non-conducting vessel is mostly made up of glass, and the other components, electrodes and electrolytes, are placed inside this non-conducting vessel. Electrodes are metal plates or wires or graphite rods which are held apart and dipped in a solution called the electrolyte. The solution is called electrolytes, and electrolytes are substances which allow electric current to pass through them. They are taken in the molten, or we can call it aqueous state. To drive the chemical change, the electrodes are connected to the external energy source, that is battery. The electrode connected to the positive terminal of the battery is called anode. Okay, the positive terminal battery is anode, and one connected to the negative terminal is called cathode. So let's see one procedure here about electrolysis. Here we have to take a solution of 1 gram copper sulfate in 50 ml water in 100 ml capacity beaker, and then use a thick plate of copper as anode and a carbon rod as cathode. Arrange the apparatus as shown in the figure and pass an electric current through the circuit for some time. Do you see any changes in the above activity? Copper appears to have deposited on the portion of the cathode immersed in the solution. How did this happen? When an electric current started following through the circuit, the cations, that is Cu++ ions in the solution, got attracted towards the cathode. Cu, that is copper atoms, are formed when electrons coming out from the cathode combine with the Cu++ ions. A deposit of the copper appeared on the cathode. Even though the Cu++ ions in the solution were used up in this manner, the color of the solution remained the same, because while electric current was on, electrons were removed from the Cu atoms of the anode and sent to the battery through the electric wire. The Cu++ ions formed in this manner entered the solution. In this way, decomposition of the solute in the solution took place due to the electric current. This is called electrolysis. The decomposition of solute in the solution took place due to the electric current. So there are two parts in the electrolysis process. These are the cathode reaction and the anode reaction. The two parts of the electrolysis process that take place in the above activity are shown below. Yeah, here you can see that cathode reaction, Cu2 plus aqueous plus 2 electrons will give Cu solid, and anode reaction, that is the reverse, Cus gives Cu2 plus aqueous plus 2 electrons. So this is the standard electrolysis as you can see in the diagram. Just cross that. Always remember, use your brain power, it is not in your portion. If pure water is used in an electrolytic cell, current does not flow even on putting on the switch. From this we learn that pure water is a bad conductor of electricity, and we have already seen the reason behind this. The concentration of H plus and OH minus ions formed by dissociation of water is very low, only 1 into 10 raised to power minus 7 mole per liter for each ion. However, the electrical conductivity of water increases on mixing a small amount of salt or a strong acid or base in it due to their dissociation and electrolysis of water takes place. So let's see electrolysis of a water. One activity is given here. Dissolve 2 grams salt in 500 ml pure water. Take 250 ml of this solution in a 500 ml capacity beaker. Connect 2 electrical wires to the positive and negative terminals of a power supply. Remove the insulating cladding from about 2 cm portions at the other ends of the wires. These are the 2 electrodes. Fill 2 test tubes up to the brim with the prepared dilute salt solution. Invert them on the electrodes without allowing any air to enter. Start the electric current under 6 volt potential difference from the power supply. Observe that happens in the test tube after some time. Did you see the gas bubbles forming near the electrodes in the test tube? Are these gases heavier or lighter than water? Are the volume of the gas collected over the solution in the two test tubes the same or different? You will get this answer when you will do the experiment. So it is found in the above activity that the volume of the gas formed near the cathode is double that of the gas formed near the anode. Scientists have shown that hydrogen gas is formed near the cathode and oxygen gas near the anode. From this, it is clear that electrolysis of water has taken place and its constituent elements have been released. The concerned electrode reaction are as follows. Cathode reaction, 2H2O plus 2 electron gives H2 gas plus 2OH minus aqueous. Anode reaction, 2H2O liquid gives O2 gas plus 4H plus aqueous plus 4 electrons. Now test the solution in the two test tubes with litmus paper. What do you see? And repeat the activity by using dilute H2SO4 as well as dilute NaOH as the electrolyte. See, all this experiment, all these questions we will see when we will do the live class on Google Meet. Till then you just revised it, practiced it, studied it. Okay, there are many applications of electrolysis of electrolytes. You can collect that information about them. Okay, next class we will revise all these lessons and all these topics also, which maybe you have understood or not. We will repeat these topics. Till then, this is the end of this lesson, so you can start to write down the exercise questions on your workbook, and after that we will do the revision of this lesson, and after that all lessons of the second evaluation. Till then, keep practicing, keep learning. Thank you.